So for this segment, we're going to be welding blue taper edge band. We have this in 3 different colors. It's blue, green, and red. And the only difference is the thickness of this edge right here. Now what this is for is if you ever have any experience putting up drywall or gypsum board or wall board or whatever you may call it in your region, there's always a taper on the edge so that people that spackle it or mud it or, again, whatever your region calls it, they have a slight depression to put that in to make a smooth seam. So this is what actually forms that when they're forming drywall. So different areas require different recesses, so that's why we have the different thickness of taper edge band. That being said, if you're using the blue taper edge band, you need the welder for the blue taper edge band because we have it shaped exactly to the size of the belt. So if you're using the green taper edge band, you need the welder for the green, and same as the red. So setup here is pretty simple. So what I'm going to actually do is just cut a chunk of this off, and it's going to simulate putting the ends of a belt together. Now, these belts are extremely long. They go around a very large section of conveyor, so they would already be around the conveyor. But for our demonstration purposes here, we're just going to take a piece and weld it, just so you can see how the weld works. So we're going to simulate that this is our belt coming in from either end. So it's going around a big conveyor. I have the smooth side up. That's what I'm going to weld with, is the smooth side up, and the thick side is to the front of the welder. So right now they just have straight cuts. Well, what we want to do, I'll move this out of the way so we can see, is we have this template, and we're going to draw a line using this template. And I'm going to cut that out along that curve. The reason that we do that is that gives you a lot more surface area to weld. You know, you always learn in school that the shortest distance is a straight line. That's absolutely true. So if we have just a straight line, that's less surface area that we have to weld. So we're going to weld it with this curve. Now, I'm left-handed, and I'm going to use these, even though they're meant for righties, but that's all right. I usually struggle through. I'll use it in my right hand. So what we want to do is follow this line. Now, these snips obviously come with the kit. You can use scissors if you want, or whatever's easier for you to cut it. That is strictly up to you. But this is what comes with the kit. I find that it is much easier with a good pair of scissors or shears. But again, since we're doing a training based on the kit that we have, I'm going to use these. And I've had some practice doing this, so generally I can get away with it. So we have our curve. Now, some people will say, well, why not just use this template to put the same curve over here? You could do that if you've cut this out perfectly. If you haven't cut it out perfectly, you want to use this as your template for your next line. So for the sake of this, I'm going to use this as my template. Now that being said, I better cut this one out correctly or I'm starting over. With enough practice, you can get these shears down pretty well. So there, I've got my templates set up. That looks like that's going to be pretty good. I got them lined up fairly well. So this is our welder. We're going to start off with it cold, because obviously you can't be having this thing up at temperature and be handling it to try and set the belt up. So you want it at temperature. You can cheat and use a pair of gloves if you want, but you still set this up cold. These will be for when we go to tear it apart later. So this is the actual heater. There's a heater on top, there's a heater on the bottom. And this is the plate that actually holds it down. So if you're going to just slide this under here, how do you know where to stop that your cut is under the blade? You really don't. Now there's a couple ways you can do it. You can measure it from there to there, from this plate to the center. You can get that measurement and then measure from the end to there. What I do is I just kind of hold it there. Gives me a pretty good idea where it's going to be at, and I eyeball it and I make my mark. So I make a mark on the belt, just a little mark there, and then I slide that under, and I slide it under to my mark. That way I know where to stop with it.
So you know that joint is dead in the middle of the...
So I know that joint is dead in the middle of the heater. That's where I want it to be. There's also a little bit of play back and forth. You want to make sure that your thick side is all the way against the front. So now, because this is really tight, a tight fit because it's made directly for this belt, some people will then also make a mark here. That's great, you can do that. But what I do is I slide this under and I just hold a little bit of pressure down on there and I slide it till I can't slide it anymore. I know that I am butted up against the other belt. And that's how I set it up. So
if you push that hard, does that push that belt out?
If you push hard enough, it will.
On that side.
But the nice thing is I have my mark there that will show me that that happened.
Right.
So now we're going to tighten these up. Now, yes, this has springs on it. So a lot of people think, well, I just need to tighten it down until there's some spring tension. That's not really the case. You want to bottom that spring out. Now, I'm going to tell you from experience, don't bottom it out, bottom it out. Back it off a little bit after you bottom it out. Reason being is when this thing heats up, metal expands when it heats up. So what's going to happen is that spring's going to expand, everything's going to expand, and that spring will bind up, and you're going to have a heck of a time loosening those wing nuts if you totally bottom that spring out. So that's just from experience thing that you're gonna learn. So just in the interest of making your life a little easier when you go to take these out and to not have to fumble in front of the customer, that's how you want to do it. We're set up. It's in there, it's ready to be welded. Move all this other stuff out of the way. So here's our control box. I want to talk a little bit about this. So it's got a 3-position switch. In the middle is off. If you put the switch up, you get this orange indicator light. And also your temperature controller turns on. So you'll see a couple numbers on there. This number on the bottom is 410. That's 410 degrees Fahrenheit. That is the SV, or set value. That's what we want this heater to come up to when the heater part is turned on. But right now it's just in monitor mode. We're just monitoring what the temperature actually is. The temperature right now is 73 degrees. So that's what this temperature is 73 degrees. And it'll just sit there like that so you can see what it is. So that says PV. That stands for process value. This is our process. When we're ready to weld, we're going to switch that down. This red light's going to come on. And this heater's you're going to see this temperature start to come up because the heater is turned on. What we're going to do is we're going to bring this up to 410 degrees Fahrenheit. Once it's up to 410 degrees Fahrenheit, we shut it off. We don't dwell there, we shut it off.
How long is that going to set?
Again, depending on ambient conditions, could take 6 to 10 minutes, depending on ambient conditions. If we were, again, in a cooler, which you're not going to be running TEB in a cooler, but it could be pretty cool. I know a lot of those warehouses have tons of big garage doors. They may have them all open and it may be kind of cool inside. It really depends on the ambient conditions, but yes, I'd say 6 to 10 minutes. So we're going to just go ahead and let this heat up for a while. All right, so we've let this get to 410 degrees. We're going to shut it off immediately. Now, the temperature is going to climb a little bit more. There's a bit of a lag in the temperature feedback. Not a big deal, but we want to shut it off. So I didn't turn it off. I turned the heater off, so now I'm in monitor mode. So we need to let this cool down to 170 degrees Fahrenheit. Now, we can let it take forever to cool down on its own, or we can get compressed air and actually blow on the welder to cool it off. Don't just sit in one spot. All right, you want to wave it all over, you want to get it underneath, you want to get all over the place. When you blow underneath, you'll see that temperature drop off real quick. That's because the thermocouple is under there, and you'll see the temperature then come back up when you stop blowing air. So don't be fooled if you're blowing under there and it seems to come down under 170 and think you're done. Actually watch the temperature, make sure it levels out at 170. So this is going to take a while. This will probably take about, again, 6 to 10 minutes depending on your airflow and all that fun stuff. So I'm going to go ahead and get going on this. All right, we are now down below 170 degrees, well below actually, so that's good. If you have a hard time with higher temperatures, go ahead and get yourself a pair of gloves to handle this. Don't the wing nuts and all that are pretty cool at this point, but the actual platen is pretty hot yet. So just be careful. And if you're questioning it, go ahead and put some gloves on. Now you can hear that grinding as I open that up. That is why I said not to bottom them out entirely, because it will bind up at the higher temperatures. Gonna get that one down out of the way, and that bound up. There we go. I'm going to flip that down out of the way. The reason these flip down is, again, you have to remember this is a continuous belt now around a conveyor, so we have to slide this welder out the back of it. Now, this is where this brass scraper comes in. Sometimes the melt will go around and get stuck around the screws or around the front of the screws or whatever the case may be. So we need to kind of pry it up out a little bit. We don't want to tear up the actual welder, so we have this brass scraper to just kind of pop everything free. All right, so we've got that free. We're going to work the belt out. Now again, normally we'd be working the welder out the back of the belt, but you'll end up with a welded belt. You can see you got a little bit of run right there, so we need to trim that off. We're going to use these snips, or again a pair of scissors if you prefer, which I typically prefer. Just because you get a nicer cut from a pair of scissors and they're easier to handle.
And again, the weld's not a weak point on the belt, is it?
Absolutely not. As with anything else, it's just as strong as the rest of the belt. So I've cut off the excess. You can see my line where I made my seam, but you can also see that that belt is perfectly welded.
What are those two little, like those two little blimps?
So what these are is it's just from them being heated, not being supported. So they kind of just, it wants to sag a little bit when it warms up. Usually once you put this under tension on the conveyor, they'll pull right out. You won't even notice them. If it's something that you want to avoid right from the get-go, you can put a couple blocks of wood under there just to support the belt so that you don't get that sag. It's really a non-issue, but again, if it's something the customer has a concern about, you can certainly support the belt out, you know, just put a couple 2x4s or some sort of block of wood under there to help support the belt. But that is a proper taper edge band belt weld.
Can I ask a question?
Sure.
You're heating that block up to 410 degrees. Mm-hmm. Customers are going to put that on top of the rubber belt. Mm-hmm. Is that going to damage the rubber belt?
We've got some rubber feet on there to help insulate that. So it shouldn't be a problem. If it's a concern, place a piece of wood underneath it just to insulate it. Absolutely. And that's it for TEB.